US Physics Olympiad, year 2018. F equal MA. Exam B. In this year, this exam was splitted by 2 different days, and you can participate either in day A or day B. That was the same condition for participation. 25 problems for 75 minutes. Please subscribe for this channel to get more interesting problems. Problem number 1. A large lump of clay is dropped off of a wall and lands on the ground. Which graph best represents the acceleration of the center of mass of the clay as a function of time? Solution for problem number 1. During free fall, the acceleration is constant and approximately negative 10 meters per second square. It spikes up during the landing and remains zero afterward. If we check all possibilities here, we have only such behavior for acceleration in case B. Initially that's negative, after that it spikes positive, and after that it remains zero. Such behavior we can see only on case B. Other cases they are wrong. So that was a solution for problem number 1. Problem number 2. A uniform block of mass 10 kg is released at rest from the top of an incline with a length 10 meters and inclination 30 degrees, and slides to the bottom. The coefficients of static and kinetic friction are mu static equal mu kinematic equal 0.1. How much energy is dissipated due to friction? Solution for problem number 2. To solve this problem, we need to find what is work done by force of friction, and this work equal to force of friction multiplied by distance, which is 10 meters, and we have this expression: work equal force of friction, which is mu k multiplied by mg cosine theta and multiplied by distance L. After putting numbers, we have 87 joules. This is the answer D, and this is a correct solution for problem number 2. Problem number 3. A 3 kg mass moving at 40 meters per second to the right collides with and sticks to a 2 kg mass traveling at 20 meters per second to the right. After the collision, the kinetic energy of the system is closest to. Solution for problem number 3. Because this collision is absolutely inelastic, first we can find what is the speed of center of mass. That will be this expression. After that we can find what is total kinetic energy. That will be this expression, and after when we put numbers, we have 2560 joules, which is closest to answer C, 2600 joules. And this is the answer for question C, and this is correct solution for problem number 3. Problem number 4. A basketball is released from rest and bounces on the ground. Considering only the ball just before and just after the bounce, which of the following statements must be true? Solution for problem number 4. The momentum of the ball isn't conserved since it experienced an external force from the ground. The kinetic energy isn't conserved either, as the sum of it is dissipated into sound waves, vibration of the ground, vibration of the ball, etc. So it means that the correct answer is E. Neither the kinetic energy of the ball nor the momentum is conserved. That was solution for problem number 4. Problem number 5. The hard disk in a computer will spin up to speed with 10 rotations, but when turned off, will spin through 50 rotations before coming to a stop. Assuming the hard disk has a constant angular acceleration alpha 1 and the angular deceleration alpha 2, the ratio alpha 1 over alpha 2 is next one. Solution for problem number 5. From one hand we have during acceleration final angular speed omega square equal 2 alpha 1 theta 1. From other hand, this omega square equal 2 alpha 2 theta 2. It means that alpha 1 multiplied by theta 1 equal alpha 2 multiplied by theta 2, and from here we can find that alpha 1 over alpha 2 equal theta 2 over theta 1, which is 5. This is answer D, and this is a solution for problem number 5.